So hi everyone. Now in this class we are going to discuss addressing modes. So program is nothing but sequence of instruction. Instruction means each command in the program we can call it as instruction. And machine language, program written in machine language is referred to as the machine language code, and assembly language is in 8086 we can write a program in assembly language only. One of the command here we have given, that is addition operation based. So ADD AX comma PX. So what is this AX BX? We know already, last class we discussed. AX means accumulator register, BX means base register. So these two are general purpose registers and these two are 16-bit registers. Now ADD is nothing but opcode. So we are going to perform certain operation. Which operation we are going to perform? Addition operation. So that will be indicated by this opcode. Opcode is nothing but operation code, or we can say it is a mnemonic. And AX, first register or first location, whichever is there first, that operand is destination operand and next operand will be source operand. So remember, first operand will be destination, next operand will be source operand. Which operation you are going to perform, that will be indicated as opcode, and the operation you are going to perform on which is nothing but operand. Which operation we are going to perform will be indicated by opcode. The operation you are going to perform on which one, whether it is you are going to perform on the data, right, memory locations, right, they are called operand. So remember, this is the general, for your understanding purpose we have given one particular command, right. Now we'll see addressing modes. So addressing mode refers the way how we are specifying the operand in an instruction, in any instruction. Okay, generally instruction means this one is one instruction. In this instruction, how you are representing, how you are specifying your operands. Here we are specifying the operands with register names, right. So like that, how you are in the way how you are going to specify the operand in an instruction, that is called addressing mode. If suppose here in this instruction I am using register names, right, then this is register addressing mode, like that. I hope you understand what is addressing modes. Okay, addressing mode specifies how to calculate the effective memory address of an operand. So we'll see this and all one by one. So these are the addressing modes we have. First one is register addressing mode, next one is immediate addressing mode, and next is memory related. Those are direct addressing mode, indirect addressing mode, indexed addressing mode, base addressing mode, then base indexed addressing mode, and next one is relative addressing modes. They are relative base addressing modes, relative indexed addressing modes, then relative base index addressing modes. The last one is implied or implicit addressing modes. So these are the addressing modes we have. So from the name only you can understand which type of addressing mode is that. So one by one we will discuss all these addressing modes. So first one, register addressing mode. From the name only I can understand I am going to specify my operands with register names. Okay. So see here operand, this is the destination operand, this is the source operand. Both the operands specified with registers. Both the operands specified with register. So that's what they given here in this type of addressing mode. Both operands are register. Okay. So now what what operation we are going to perform here? Move operation. Move means data you are going to transfer from CL to AL. It's like a copy paste. You are going to copy the value which is in CL to AL. Okay. So now in CL, the 8-bit data 25 I have. 8-bit data is there in CL. We know very well CL is 8-bit register. So this 8-bit register has 25 8-bit data. This 25 data we are going to copy in this AL. We are going to transfer this data to AL. Okay. So see the next slide. See now AL is changed to 25. After execution this instruction, now AL value is changed to 25. Right. So this is register addressing mode. Next one, immediate addressing mode. Here I am going to, in this addressing mode, source operand directly we will use 8-bit data or 16-bit data. Directly we will use the particular data value. Okay. So that kind of addressing mode is called immediate addressing mode. This kind of addressing modes are called immediate addressing mode. So see here, destination won't be immediate data. Remember, destination operand won't be an immediate data. Only source operand will be a immediate data. Either it may be a 8-bit data or 16-bit data. So see this instruction. Here I have given 16-bit data directly to 000. This is 16-bit data directly given. According to this instruction, what we are going to perform? We are going to copy this 2000 in this AX, in this register, right? So AX is nothing but combination of AL and AH. So AL stores the lower byte, that is 00. AH stores higher byte, that is 20. Okay. So this 2000 is somewhere in the external memory here. Now this value we are going to copy here in these two registers AH and AL, because AX is nothing but combination of AH and AL. So see here, after executing this instruction, now in AL 00 stored, in AH 20 stored. So if you combine this 20 and 00, finally you will get 2000 value. Okay, this is immediate addressing mode. Next one, direct addressing mode. So direct addressing mode means in the source operand we will specify, source or destination operand, we will specify the memory address. 16-bit memory address or input output address is directly specified in the instruction. So see here, remember inside the square bracket, if like this 4 values, if it is given inside the square bracket, 4 values like this, if it is given like this, then you should understand this is an offset address. This is a distance from the base location. Offset nothing but distance, right? So now move instruction we know. By using this move instruction, it is like a copy paste, right? You are going to paste the value which is there in this location to CL, right? So move instruction just moves the data from location to CL. So first we need to find out the location. So 4321 only given, right? And this offset associate with always data segment. Remember, this kind of instructions always associated with data segment. So in the next slide I have given how to calculate. See, base address of the data segment, base address, or we can say segment address. Segment address is actually 5000. See, we assume that data segment address is 5000 and offset given 4321, and we know the formula to calculate physical address. So formula is segment address into 10 plus offset address, right? So segment address value is 5000, 5000 into 10 plus 4321. So when you multiply 5000 into 10, you will get 50,000 plus 4321. Then you will get 54321. It is not 50,000 because it is in hexadecimal value. It is not 5000. Just for this one I am telling, it is actually 5000. That's it. 5000 into 10 plus 4321. So which is equal to 54321 H. So this is the physical address where your data is located. Okay. So we are going to fetch the data and we are going to store in this CL register. Whichever the data is there in this location. Okay, now see this one. The base address is 50000 and the distance is 4321. Then we travel till here. Now I reached 54321. In this memory location, my required 8-bit data is there. That 8-bit data is 11110000. That 8-bit data now we transfer and stored in this CL. I hope you understood what is this move instruction performing. This particular instruction is performing the data transfer from this memory location to CL register. Previously we discussed register to register and data directly to register, right? That is immediate addressing mode. Now direct addressing mode means from the memory location to register. I hope you understand this direct mode. Next one is indirect mode. Here also memory location they given, but memory location previously you see the offset value they given, but now they given the register where the offset value is stored. In this SI register offset value is there. So only that SI register they given inside the square bracket. So that this type of addressing modes are called indirect addressing mode. So in this addressing mode, offset is either in any one of these registers, BX, SI or DI. These registers hold offset value. Okay. If that offset value directly given, then it is called direct addressing mode. If it is given with any one of these registers, then it is indirect addressing mode. And again, as I told you, default segment is DS or ES segment. Here we have taken data segment only. Whenever we are taking SIDI, that time along with data segment, extra segment also will come. Okay. Now we have taken one example instruction, move AL comma SI, and whenever a square bracket is given, remember that it is an offset, it is a memory location. Okay. Now we should consider, we should assume that DS start from 5000 and SI content is 1102. Content of SI is 1102 we assumed. Okay. Now we know how to calculate 20-bit physical address. The formula is segment address into 10 plus SI plus the offset. Okay. So segment address is 5000 into 10 become 50000 plus offset is 1102. Add this value, then you will get the physical address, that is 51102. So in this location 8-bit data is there. That 8-bit data I am going to move from here to AL. Okay, now I am going to copy paste. Move instruction is it's just like a copy paste. So first we'll see the external memory. This is the external memory of 1 megabyte size, right? So here we have taken only data segment, data segment size is 64 kilobyte. Okay, this is of 64 kilobyte. So now directly I have given. So it starts from 50000 and your required location is here, and in this required location is actually 51102, that is here. So in this 8-bit data, what 8-bit data I have? F0 I have. So that F0 I am going to transfer to AL. Then that F0 is now stored in AL. Okay. So I hope you understand what is indirect addressing mode. Now next one is memory based addressing mode. So based means, remember, if based addressing mode means base registers will come. These base registers will give the offset or we can say effective address. Okay. So we will use either BX or BP in the instruction. Okay. So see here, example move instruction we given, move DL comma inside the square bracket BX is given. So in the register, see this, in the register addressing mode, see in this example, see BX they given without square bracket. If they given like this, then you should understand that whatever the data is there, 16-bit data is there in BX, that we are going to add that value with this. That is this add ADD, right? If we given with square bracket, if it is given with square bracket, see here that same BX given with square bracket, then this is nothing but memory location. It is not a data, it is a memory location, right? So same last case we had seen SI, right? So this is also a memory location. This is also an offset, right? It holds 16-bit value. Similarly, this BX also holds 16-bit offset value. So see here. So BX, we are assuming DS start from 50000 and BX holds 16-bit offset, that is 0005, and we know how to calculate physical address. The formula is segment address into 10 plus offset. So after calculating, we are getting physical address is this one, 50005. So this is the location. In this location 8-bit data is there. That 8-bit data we are going to transfer to DL. Okay. Now base address is given here. Base address of data segment is given here. That is 50000. And the offset is 0005. Okay, now offset, or we can say effective address or offset address. So if I travel 0005 distance, then I can reach this memory location. Okay. Then what is the value, 8-bit value stored in this location? F0. So that F0, so see here, I traveled 0005 distance, then I reached 50005. In this memory location, there is a 8-bit data, that is F0. That 8-bit data we are going to transfer to DL. So I hope you understand this based addressing mode. The next one is indexed addressing mode. So from the name indexed, by seeing this index, we should understand that we will use SI or DI inside the square bracket. So previously we used SI, but this is actually SI, DI as well as base value, base register values also you can use inside the square bracket. Okay, that time commonly it can be represented as indirect addressing mode. If one of this register we used inside the square bracket, that time it is indirect addressing mode. Particularly if I use base register, then it is based addressing mode. Similar, particularly if I use index register, then it is index addressing mode. See here I used particularly base register, so it is base addressing mode. If particularly I used index registers SI or DI, then I can say that is indexed addressing mode. And remember, inside the square bracket, if it is given, then it is an offset. It is not a data. It is an offset. It is a memory location. Okay, no. Now see. Now instruction is move DL comma SI. So we need to track this one, how to calculate physical address and all, you know very well. So it has the 16-bit offset, and we should add this with the segment address. Then we will reach this required location. In this location 8-bit data is there, that is F0. That F0 will be transferred to this register DL. I hope you understand this indexed addressing mode. The next one is based index, which means combination of base register as well as index register. If both comes, so that time we can call it as, that particular addressing mode we can call it as based index addressing mode. So in this we can use BX or BP, SI or DI. So here we use BX and SI, both are in addition, and both are this sum we have given inside the square bracket. Remember, whenever square bracket is there, then this is nothing but an offset value, or we can say it is a memory location, or we can say it is a distance from the base address. Now we see the 8-bit value which is there in this required location, that 8-bit value we transfer to this CH, okay, whichever is there in this required location. You know already how to calculate the physical address and how to reach this location, memory location, by using this offset value. Okay, I hope you understand this based index addressing mode. Next one is relative based addressing mode. Memory based addressing mode we discussed. Now relative based, relative whenever comes, inside the square bracket displacements will be there. Displacement means distance values they will give like this. See here 8-bit displacement they given 04. So in the instruction 8-bit or 16-bit displacement also been given. This also been given in the instruction, okay, to calculate the offset address or to calculate the memory location. Both are same, right? So remember, here we used base register, that's why it is called relative base. In the next case, see, I will show you. In the next case I use index register, so that it is called relative index. Along with index register, displacement also there. If displacement is there, then we can call it as relative index. Okay. So see here, if from this memory location we are going to transfer this F0 to CH here, from F here to this memory location to CH. So see this, I moved that F0 to CH. I hope you understand this relative base. Next is relative index. Only difference is in place of BX I have taken SI, that's it. Okay, and displacement might be either 8-bit or 16-bit. Here I have taken 8-bit displacement. So now we'll see. So see here, from this memory location we transfer that F0 to here to CH, right? I hope you understand this addressing mode. Next one is base index together. So base register and index register together, along with that displacement also will be there. So this also having 16-bit offset, and this also having 16-bit offset, and both 16-bit offset you should add, and this 4 also you should add with that. Then you will get 4 hexadecimal value, right? That is your offset. Okay, and with that offset you should find out the required location. In that required location F0 is there. That F0 I transfer to CH register. I hope you understand this base index addressing mode. So the last one, implied addressing mode, or we can say implicit addressing mode, both are same. So implied addressing mode means separate operands will not be there in this kind of addressing modes. Directly they will give, this is implied. So STC or CLC. STC means this sets the carry flag. This sets the carry flag 1. STC if I give, it sets the carry flag. If carry flag set means it will show 1, right? CLC means clear the carry flag. CLD means clears the direction flag. So see here, direction flag cleared. Now it is showing 0. So like that, like this kind of instruction if we use, then those instructions, such kind of specifications, we can call it as implied or implicit addressing mode. I hope you understand all the addressing modes, start from register addressing mode to implied addressing mode. Thank you all.